So for number 1, when you look at it, I think most of you are good with drawing line 1, y-intercept is 4, slope -1. So you draw this line, and then you draw the second line, y-intercept of 7, slope of 2. You're trying to see where these lines cross. If they do, they cross at one spot. That is why there is one solution. And when there is one solution, we know that there consists an answer. So it's consistent. And what type of answer? One answer. That's why we say independent. So consists means there's an answer, and independent means one answer. When you graph the next one, you get parallel lines. Solutions are where things run into one another. Parallel lines never touch, therefore there's no solution. Then we say inconsistent. You don't say dependent or independent. You just say inconsistent, there's no answer. For this next one, you first have to isolate a variable. Pick the one that has a coefficient of 1 in front. So the bottom y is easiest to isolate. You isolate it by subtracting 3x from both sides, and once y is isolated, you take -3x plus 10 and you insert it into the y spot in the other equation. Therefore, that gets you 3x plus 4 times the quantity -3x plus 10. Once you distribute and solve, you get x equals 4. Once you get your x answer, you get to go back to either of the original equations. I chose to go back to the bottom one that was rearranged, and I plugged in 4 in the x spot and got -2 as y. Therefore, there is one solution. Again, we would say consistent and independent. And where these two lines cross is at 4, -2. So number 4 is the same example of substitution. So I'm going to skip over that one. But let's look at number 5. So for elimination, you have to pick what variable you want to eliminate. You can do either first. So I zoned in on the y's. I say to myself, how can I eliminate them? I want their signs to be opposite. They're both positive, so I'm going to multiply one by a negative and multiply by the opposite coefficient. That's why I multiplied the top by 1 and the bottom by 4. Once you distribute to all terms on both sides of the equation, you get this top row right here. Once you distribute the 4 to the bottom, you get this equation over here. When you add them up, your y's cancel out. Therefore, you're left with 5x equals 35, giving you x is 7. Then you go to either equation, plug in 7. So I went to the bottom, solve, and you get y is -6. So these lines cross at one spot at 7, -6. Notice for number 6, you do the same method, and when you do elimination, all the variables disappear. When there's nothing left on a side, you put a 0 as a placeholder. 0. If it's a true statement but variables cancel, then that's when there's many solutions. Because if you graph, it's the same line written 2 times. Now we're going to focus on number 10 because that's one of the harder inequalities. So if we look at number 10, we need to graph each inequality separately. So I used 3 different colors. For this top one, I used green. So if you follow the green, that's what I used to graph. I think a lot of you like to isolate y. So to isolate, we subtract 4x from both sides. We then divide by 5 to each term. So then we plot our y-intercept is 3. So it was right about here. Our slope was -4/5. So we went down and to the right, down to the right, and that's how we got this full shade line. You then test a point for this green line. I tested 0, 0 because that was under the line. When you test 0, 0, when you plug it in for x and y, it's a false statement, meaning do not shade the 0, 0 side. Don't shade that side, so shade the other. And that's why we shaded the opposite side for the green line. Now let's focus on the blue. So this middle one. A lot of people had trouble with this today in class. If x is greater than y, you can rewrite that. It's the same as y is less than x. All this is saying, if you think about it as y equals mx plus b, the y-intercept is 0, so it touches at the origin, and the slope is 1. So you just go up 1 over 1. So that's how we get this dotted blue line. Because this blue goes through the origin, you can't test 0, 0. But since y is isolated and it says y is less than, we shade under the blue line, or you can test a point. Lastly, for this pink one, x less than or equal to 5, remember Hoy Vux, V-U-X. X means it's vertical, so it's a vertical line that goes through x5, and less than, we shade to the left. Our solutions are all in this multi-shaded region. Last one, setting up the word problem. So look for what it's asking at the very end. How many adult tickets were sold? That means the variable needs to represent the number, not the cost. So when we set up our variables, we know they're going to be for an amount, not the cost. We already know the cost. So it's the amount of tickets, how many tickets were sold. So we'll say X is adults, Y student tickets. And again, it's the amount of tickets. So for our first equation, this is a cost equation. If this is the total that they make, since it's a money cost equation, the worth needs to go in front of the variables. So each adult ticket costs $3. Each student ticket costs $1.50, totaling this money amount. It's a cost or money equation. Versus the bottom one is just an amount. Sum of the adult tickets plus some student tickets equals 170 tickets. Once you get those two equations, you can use any method to solve. You can use the matrix option with your calculator, or if you want to do substitution or elimination, go for that. So I will solve this one using elimination. So I'm going to multiply the whole bottom row by. So we now are going to multiply the bottom row by -3. We get negative, oops. We're going to get negative 3x minus 3y is equal to negative 510. So when we add these up, the x's cancel. We have negative 1.5y is equal to negative 30. We divide by negative 1.5. So then we get y is 20. So y is student tickets. So we sold 20 student tickets. When we go back to plug that into either equation, I'm going to go to the bottom one. I'll have x plus 20 is 170. So x is 150. And that's what they're looking for, adult tickets sold.